Okay, here's our week 14 review video. I'm going to go through all the problems, but first, this is what I gave you at the end of class today. And this is just a little cheat on your exponent rules. So you may want to look over these and make sure you understand when are you supposed to be adding the exponents or the fractions, and how do you do that? When are you supposed to multiply them, and when are you supposed to subtract them? So you are welcome to write this down or study it however you need to. All right, and let's start just looking at some questions. I'm going to look through 1 through 4, look at 1 through 4 as a set. 1 through 4, all they're wanting me to do is write them in the other format. So remember that when you do that, you have a fraction. The top is powers, and then the bottom is roots. So you can think about people rise to power, and then roots are on trees and they grow in the ground on the bottom. So that's how you, maybe one way that you can kind of remember that. So the first one is just going to be b to the power on the top. So 5 is my power. Root on the bottom to the 5/3. Simple as that. Question number 2, same idea. This time I'm doing all of 2n, so I'm going to put it in parentheses so that I know that it's everything and not just the n. All right, same idea. 5 is the power, 3 is the root. All right. Number 3 and 4 are that same concept, except we're going backwards. So this time I'm going to write a root. I know the root's on the bottom, so it's the 6th root of 2m to the 5th power. And you want to make sure, you want to make sure that this 5 is like being applied to the whole square root and not just to the m, because it's not being applied to the m, it's being applied to everything. And then our other one, this is the bottom number is the cube root of 3x. And since it's to the first power, I don't even really have to write the 1. That's just what my problem is going to be. So make sure you know powers and roots. Okay, 5 through 7 are very similar. Because they have them written as roots, we want to break down what they've given us. So I'm not actually going to go through that part. That's just a factor tree, but I am going to write what you have once you break that down. Okay, so on 7, if I expand everything out, this is what I get. You all know square roots mean you have to have pairs to pull things out. So I've got a pair of 2's that can come out, 3, a whole number 3, and a quote-unquote whole number x. Those all come out as single numbers, so I've got 2 times 3 times x on the outside, and then I have a 2 and a y that are stuck on the inside. They don't have anything they can pair with. The only thing you have left to do now is maybe just write this in a neater way, which is I can multiply that. So 2 times 3 is 6x, the square root of 2y, and that is your final answer. Okay, again, I went ahead and broke down 128 on my own. This time, because it's the 6th root, I have to have a whole group of 6 to bring even one whole number out. So if I circle, I've got this group of 6, and that just brings out one whole number. There are no other groups of 6. If I look, there's no other groups of 6 in this area, so I can't bring anything else out. So I've got a 2 on the outside. And then, since none of the stuff on the inside can go back together, this is going to be the 6th root of 2xy squared. There's my final answer there. Remember, you have to have a group of 6 on this one to be able to pull out. That goes for the variables as well. Okay, here, my exponent says I need to have groups of 3 to be able to bring out whole numbers. So there's 1. There's an x, got a y. So here I've got 2xy on the outside. Oh, and I forgot a y when I wrote it. And then stuck on the inside are the cube root. Make sure you put the 3. That's going to be wrong if you forget that tomorrow. 7y. All right, there's my final answer. Okay, this question goes back to the rule, the page before when we talked about the rules for exponents. So my whole numbers I can go ahead and multiply together. 4 times 2 is 8. 8 times 3 is 24. And then if I look at all these A pieces, they're being multiplied, which when I remember my rule tells me I need to add. So I'm trying to add 3 halves plus 4/3 plus 4/3. I need like denominators, so I'm going to make everything into sixes. That's the easiest thing to do. So times 3 times 3 times 2 times 2. All right, so I'm going to have 9 over 6, 8 over 6, plus 8 over 6. So we add all the numerators together, which is going to give us 25 over 6. This is my exponent. Okay, it's not my answer. So my answer is the whole number 24a to the power 25 over 6. You know you're done because there's only one a left. If you still had another a somewhere with an exponent, you wouldn't be finished. But now that you only have one a, that's how you know you're finished. Okay, my rule here, if I have a power to a power, my rule is to multiply. And when I multiply fractions, I just multiply straight across. So that's 5 over 6, which is my exponent. So my answer is n to the 5/6 power. Only one n left, only one power, so I know I'm done. Here, these are being multiplied, so I know I'm going to need to add my exponents. That is 1/2 plus, make 3 a fraction, 3 over 1. Like denominators would be 2. So I'm going to multiply, this is 1/2 plus 6 over 2, which if I add that, I get 7 over 2. Remember, that's my exponent, so your answer is r to the 7/2 power. Okay, 11 here is almost too easy. Normally, when you would divide, you would subtract, and I guess technically that's what we're doing here. This is x to the 1, x to the 1, 1 minus 1 is 0. But most of you are just going to look at that and say, those x's just cancel each other out. So the answer, your final answer, is just 3 over 4. And all this exponent of 0 would mean is that you have 0 x's in your final answer. So either way you think about that, 3 over 4, that one's pretty simple. All right, this one has a few things going on. Because this fraction bar is like the biggest thing going on, you have to do it last. So the first thing I need to do is take care of the bottom. So I'm even going to do one step before I do that. I'm going to multiply those 4's together. So I've got 3p to the 1/2 over 16 p squared p to the 3/4. So now I need to work this out, which means I need to add because that's a multiplication problem. So 2 over 1 plus 3 over 4. I need like denominators, which is going to give me 8 over 4 plus 3 over 4. That's 11 over 4. So my original problem has now become, I'll just work down here, this is my kind of fraction work off to the side, 3p to the 1/2 over 16p to the 11 over 4. All right, now I've got a division problem going on. Division means I need to subtract. So I'm going to do 1/2 minus 11 over 4. Here I need like denominators again, so I'm going to fix that. That gives me 2 over 4 minus 11 over 4, which if I, that's negative 9 over 4. There's a few ways for you to think about this or write your answer, and either you can say, because the bottom is bigger, my answer will end up on the bottom. So that's 3p to the 1, oh, not p to the 1/2. The p's are gone, I forgot that. 3 over 16 p to the 9/4. Or what I think that you might even like better is just to keep the exponent negative. So that's 3/16 p to the negative 9/4. I'll try to help you tomorrow if you get really stuck on maybe where to put this answer, like where on the fraction, I can help you with that. But hopefully you understand at least the general process of how to get that, because that's what you will need to know for tomorrow. Okay, again, my big fraction bar is going to be the last thing that I do, so I got to simplify the bottom first. The top is going to say stay m to the 1/3. The bottom is powers to powers, so I need to multiply. 1/3 times 1/2. Multiply fractions straight across, that's 1/6. So I've got m to the 1/6 power. And now I have division. So this whole part is now division, which means I have to subtract my exponents. 1/3 minus 1/6. To do that, I need like denominators. 2/6 minus 1/6, and that is 1/6. So my final answer here is going to be m to the 1/6 power. All right, don't let 14 freak you out. Fractions, the last thing I deal with. So I'm going to simplify the top. The top is to multiply. All right, I'll use a different color. So we're going to do 2 over 1 times 3 over 4. Multiply straight across. That's 6 over 4. And I'm even going to simplify that to be 3 over 2, just so I have smaller numbers. So that means the top of my equation is now equal to n to the 3/2. And the bottom down here, this is multiplying, so I'm going to need to add 1/2 plus 5/3. I need like denominators, so let's work that out. So I've got 3 over 6 plus 10 over 6, which is 13 over 6. So that means the bottom is going to say n to the 13 over 6. Notice how much simpler my fraction looks now. And now all I have left to do is to take this and divide, which tells me I need to subtract my exponents. So I'll come down here and do that. That is 3/2 minus 13 over 6. A common denominator here would be 6. So that's going to give me 9 over 6 minus 13 over 6, which is negative 4 over 6, or negative 2/3. And again, you can write that one of two ways. You can either write the 2/3 on the bottom, n to the 2/3 on the bottom, because the bottom is bigger, or you can just write n to the negative 2/3. Either way, again, I'll help you with how maybe to put that in your answer tomorrow if you ever get a negative exponent, because we didn't do a great job of talking about that this week. So either one of those I'll take. Okay, last little bit here, we're solving equations. So 15 through 17 are all going to be very similar. To undo square root, we have to square both sides. Remember, the square root and the square cancel, so this is just 42 minus k. And then k squared on the other side. And k squared means you're going to have to use your calculator, which also means you need to get it to equal 0 first. So I'm going to move my 42 over and the k to the other side. So I'm going to have 0 equals k squared minus, I'll say plus k first, minus 42. If you get that order backwards, your calculator is going to figure that out, so that's not a big deal. So when you look in the table in your calculator with your x's and y's, you should be able to find zeros at -7. And if you scroll on through at +6, remember these right here are possible solutions. They are not guaranteed solutions. They're only possible, so we have to check them and make sure that they work. So to check them, we're going to plug in our calculator. So exactly what you're typing in your calculator should be 42 minus -7. And then we also want to type in, well, you don't even really have to type in the other side. The question is, does that equal -7? Notice I'm plugging that in. All right, so if you look up here, I'm plugging that into the k spot in both places in my original equation. So my calculator is going to tell me that this is +7 equals -7, and that is not true. So no, this is not an answer. All right, now I need to check 6. So let's check 6. So we're going to plug it in. 42 minus 6. And the question is, does that equal 6? When I type this first part in my calculator, I get 6. 6 equals 6. That is true. So that means this is my answer. That is an answer. So what I'm going to write then is that k does equal 6. You should make sure you check there tomorrow because I know one of your answers is going to have both of those listed. So if you don't check for ones that don't work, you're going to pick the wrong thing. All right, 16 looks worse because you've got two square roots, but it's actually going to be easier. We're going to square. And what that's going to do is cancel my square roots on both sides. So now I just have a super simple equation. I'm going to subtract 2m from both sides. Negative 8 equals negative 1m. Divide. This is like super basic algebra, right? So I've got m equals 8. And then I still do have to check. So I still need to check and make sure that it works. So the square root of 2 times 8 minus 8. And I want to know if that equals the square root of 8. So I'm going to use my calculator. And I got 2.82 blah, blah, blah. And the same thing on the other side. And because that does work, that means this is yes. So m equals 8 is one of my final, or it is my final answer. It's the only one I have to check, and it does work. All right, 17. The only thing you might want to do, remember root. The 2 is a root, so you might want to rewrite this. You don't have to, but it helps. I think it's been helping some of you to rewrite it. So I need to undo the square root, so I'm going to square it. So I'm just left with 6m minus 11. On the other side, you all know that means you have to write it twice. So m minus 3, m minus 3. I'm going to have to multiply, so the left side will stay the same. That's m squared. M times negative 3 is negative 3m. Now I'm going to distribute my negative 3. Remember, negative 3 times negative 3 is positive 9. And because I've got something squared, I know I need to use my calculator, and I know that I need to get it to equal 0. So I'm going to do a handful of things at once if you can follow. I'm going to subtract 6m so that cancels, and I'm going to add 11. You do not have to do that all at once. I'm just kind of showing you another option. So I've got 0 equals m squared, and then I have negative 3, and negative 6. If I combine all those together, I'm going to get negative 12m, and then 9 plus 11 is plus 20. If I do that in my calculator, I'm going to get answers at 2 and 10. And so these are, remember, these are possible solutions. I won't know until I check. So I'm going to plug back into my original equation. So let's check. We can check 2 first. And honestly, you can type that exactly like you see it, even with the 1/2 exponent. So in my calculator, I'm going to do 6 times 2 minus 11, all to the 1/2 power. And I want to know if that equals 2 minus 3. So I'm plugging 2 in both parts. When I do that, I'm going to get 1 and negative 1, and that is not true. So 1 does not equal negative 1. So that means 2 is not an answer. Okay, I can check again with 10. So same thing, 6 times 10 minus 11 to the 1/2 power equals, I'm not sure if it equals, I want to know, 10 minus 3. And this time I get 7 in my calculator, 7 on the other side. That does work. So that means 10 is my answer. So I'm going to say m equals 10. It doesn't always have to be that one answer doesn't work. It might be that both answers are perfectly fine. You just have to check every time. All right, the last part down here is from your calculator. This is from a previous test, but we're just remembering domain and range. Remember, domain are my x values, range are my y values. And the easiest place we said to look last time was in our calculator. So we're going to type this in y equals. All right, I went ahead and gave us our tables. So remember, you're looking for the error. So on 18, my error is going to start at, or end, I guess, at -2. So on the x side, I'm starting at -2, and then think about as you move away from the error, what's happening to the x values. And you should notice they're getting bigger. So my domain here is x greater than or equal to -2, because I'm starting at -2 and getting larger. Also, as I move through my y values away from the error, my y values are starting at 0, so I've got range is y. And then think about what they're doing. I start at 0, and then I move into the negative numbers, so my y are getting smaller. So my range is going to be y is less than or equal to 0. All right, on this other one, I just took a picture of what I had, but if I scrolled through, I never found any error. So if there is no error, that means your domain is all real numbers and your range is all real numbers. And some of you on the last test, you noticed anytime you have cube root, you're going to have all real numbers. And that will always be true. So square root does not work that way, but a cube root will always give you all real numbers. If you need help with anything, please make sure you come to tutoring in the morning. I might be at the pass table, but you can come find me, and I will help you with anything that you have questions on. Just let me know.